our topic for the day. We're just going to call this rate of change and slope. So rate of change and slope. And today is January 10th of 2022. All right. So just real quick, I'm not gonna call on you if you raise your hand for this. I just want a show of hands. Who has seen slope of a line before or rate of change? Anybody familiar? Anybody, does that sound familiar? Just show of hands. I see some people like, yeah, maybe a little bit. I see some people's hands up as well. Okay. So rate of change in slope, all it's talking about is the steepness of a line. That's really it. We're going to write a little bit more than that right here, but really we're just talking about how steep a line is. And when we're talking about a line has to be, when we say line in math, it has to be what we would consider to be a straight line. This is a line here. This right here, this would not be considered a line in math. Like in an art class, yeah, you'd probably call that a line, but line means it needs to be a constant straight line. It can't have any kind of curve or change or anything like that. It's got to be consistent in terms of it just is a nice straight line. Now it can be, it can be tilted and it could be horizontal and it could be really steep one direction or the other, but it must be a straight line in order to be a line mathematically. So rate of change, going back to that real quick, we're going to write this down. We're going to say that it is a ratio. I'll review that word in a moment. A ratio that shows how one variable changes with respect to another. So rate of change is a ratio that shows how one variable changes with respect to another. So get that written down. First of all, a reminder on a ratio. A ratio is just a comparison of two numbers, and it's a fraction pretty much all the time. You'll see slope, rate of change written as a fraction. So ratio, most of the time, ratios are written as fractions. So that's all this word means here. It's comparing one variable with another. So we're talking about like X and Y. Those are the two variables when we're graphing. So we're talking about how X changes along with how Y changes. So that's what it means, how one variable changes with respect to another. It's a comparison of how the X variable and the Y variables change over the course of a graph. And on a linear graph, this is called the slope of a line. So rate of change and slope, in terms of what we're doing in this unit, they're exactly the same. There's no difference between rate of change and slope. So our next sentence that we're going to fill in here, this first bullet point here, it says that slope is written as a ratio. So there's that word again. We're going to use the word fraction a little bit lower, but ratios and fractions are pretty much interchangeable. So slope is written as a ratio of the vertical change to the horizontal change between any 2 points on a line. So let me ask you this. Who has ever heard the phrase, or who's ever seen this before? Rise over run. How about that? Oh, I see more hands this time. Okay, so when I asked about slope and rate of change, I saw a few people, and then when you see rise over run, I saw more people going, okay, that's what we're doing. So we're talking about rise over run. So if you're talking about vertical change, these are the Y values, which means this is the rise, to the horizontal change, which we're calling the run. So this would be a Y value, and this is an X value. So it's the change in Y over the change in X. It's the rise over the run. So how far up or down does it go? And then that makes a fraction or a ratio over how far left to right it goes. And that's between any 2 points on a line. The nice thing about slope or rate of change, or whatever we want to call this, is that this remains constant. Which means it's the reason why we can use any 2 points on a line, because any 2 points that you pick on a line are going to give you the same slope of that line. So it's going to remain constant, which means you can pick any 2 points and you get the same answer no matter which 2 points you pick on the line. So we could pick, if we wanted to, if we were figuring out the slope of this line, which we're not, but if we were, we could choose these 2 points, we could choose these 2 points, or we could choose these 2 points, and we'd still end up with the same slope no matter what, between any of those 2 points that we pick. Slope is written as a fraction. So here's where we're using the word fraction, because ratios are fractions. And we're going to write it as a fraction in, how should we always write fractions? Ask for a little bit of a response on this one. Like in general, if you have a fraction, how should it always be written? Yeah, we got our numerator and denominator. But let's say it's 2 over 4. What should we do with that to make it a little cleaner? Now we're not gonna make it a decimal. We could, but with slope, we generally leave it as a fraction. Ash? Simplify it. Yeah, we're gonna write it in simplest form. So if we had the fraction 2 over 4, we would simplify that to 1 over 2. So we're gonna write it in simplest form. So slope is written as a fraction in simplest form. Now there's a specific letter, a specific variable that we use for slope, and it's not S. Does anybody remember what it is? Remember what letter we use for slope? What's that? Z? We actually don't use Z, not for slope anyway. Z actually is used, but Z is generally used in a 3D graph. So like in a 3D graph, you've got your x-axis goes left to right, your y-axis goes top to bottom, and for a 3D graph, Z goes front to back. Which we won't be doing in Algebra 1, but I think you might start in on some 3D graphs if you take Algebra 2. But the variable that we use for slope is, it's a lowercase m. Anybody remember, or does anybody recognize that formula right there? Y equals mx plus b. Oh yeah, this right here, that's our slope. So m, lowercase m is the variable that we use for slope. I don't know why, actually. I don't know why we use m for slope. I've actually tried to research it to figure it out, but I can't find a consistent answer on why m is the letter that we use for slope. It just kind of is one of those things that we're like, yep, we use it. That's it. All right, now there are 4 types of slope that we can end up with. If a line is going in an upward direction from left to right, this is what's known as a positive slope. Meaning the number that we end up with is going to be a positive number. So if it's moving from left to right, by the way, whenever you look at a graph or a line on a graph, always look at it like you're reading from a book, left to right. So if it's moving in an upward direction, that's a positive slope. If we're looking at it from left to right and it's moving in a downward direction, what do we think about that? What would we call that? A negative slope, exactly. That means that the value of m, the slope, has to be a negative number. It's got to be a negative number. There are two more. You can have a positive slope or a negative slope. What else do you think you could do with a line? How else could you draw a line aside from a positive slope or a negative slope? How about a horizontal line? Horizontal lines don't go up or down. What do you think the slope would be then? Yeah, because we're talking about the number that isn't positive or negative. That's going to be 0. Now this last one, what do you think the last one's going to be? Any ideas? Vertical line, good. This is where things get a little bit funky because we've already used 0. So that means that this can't be 0 as your slope. And it can't be positive and it can't be negative because we've already used those as well. So does anybody who's learned this before, does anybody remember what we say for the slope of a vertical line? And if you don't, that's fine. All right, here we go. We call this undefined. That is an undefined slope. It's kind of like, let me go back to our unit 3 here real quick, see if I can find an example. I'll go ahead and use this one right here. So back in unit 3, we learned about things that are functions and things that are not functions. And the thing that we learned about when something is not a function, it was the fact that you had points that were vertically on top of each other, right? If you have 2 points that are vertically on top of each other, it could not be a function. Everything that we look at in this unit is going to be a function. And since this is a vertical line and it has stacked points, that means that it is not a function. All right, Francisco. It means that it's not a function. And because it's not a function, that means it doesn't have a slope because it's not actually a line or a function. And so there's nothing really we can say about it other than it's undefined because it doesn't fit with our definition of a function. And so we have to say undefined for that. So it's a little bit of a side deal there that where we can't really do much with it. So we just leave it at that and we say that slope is undefined. All right. So what we're going to do now is to finish off this first page, and then we're going to do the exact same thing for the second page as well. And I have you work on some of those on your own. But we're going to start down here. We're going to say, all right, we're going to figure out the slope of each line. And always, I'm going to make sure I write a note of this over here. Always look from left to right for the run. I'll make sure I move that so we can see it. Always look from left to right for the run. What that means is when you're finding slope on a graph, you're using rise over run, which is the change in the y's, the change in the vertical over the change in the horizontal. When you are looking at the run, the change in the horizontal, you are always going from left to right every single time. What that means is your denominator, your bottom number, if you go from left to right on a number line, what kind of a number is that going to be every single time? A positive number, yeah, because it's going up. Every time you look at a graph from left to right, it's moving in a positive upward direction, which means when you use a graph to figure out slope, your denominator pretty much should always be a positive number because you should be looking at it from left to right. All right, so what we're going to do now is we're going to figure out the slope of these lines. Colorful with this. Let's see. Okay. Find some colors that'll show up pretty differently here. Okay, so with our rise over run, we're always going to figure out the vertical distance first. Now, between these 2 points, the nice thing about these ones is that these points are already on the graph. So what we have to do is we have to figure out, all right, how far straight up or down, not diagonally. We'll get to that in a moment. That's what the whole fraction is about. But straight up and down, how far do I have to go to get from this point down here to this point up here? So we're talking just the straight up and down vertical distance. So first of all, from this point down here on the left, this point up here on the right, are we going up or are we going down? Is it going up or is it going down? It's going up, yeah. And since it's going up, that means that the slope is positive. As you look at it from left to right, it's moving upward, which means that this slope is going to be a positive slope. So there's a couple things that we know about this already. It's a positive slope. And so we're going to go straight up. We're not going to go diagonally. We're going straight up. So if we count from here all the way up to where this point is up here, it is 1, 2, 3, 4, 5, 6, 7. So the rise is plus 7. So we've got a rise of 7. And then our run, once we've gone up to here, we're just going to count how far over do we have to go to get from the top of this arrow to this point here. I'll let you get that in on your paper. I haven't talked very much in the last 3 weeks. I think I'm going to have a sore throat at the end of the day. It's going to be like the beginning of the school year all over again. So from the top of this arrow here, we're going to count from here to this point. So that would be 1, 2, 3, 4. So we're going over, and that would be plus 4. So the rise is there, and the run is there. And so what we have to do is write a fraction using the rise over the run. So we're going to say m is equal to, the rise is 7, and the run is 4. So 7 over 4. Because we went up 7, and we went over 4. And that's our answer. That's it. Because we can't reduce that fraction. Any questions about that so far? So in terms of the math that we're doing today, we're counting. We're counting spaces up or down, and we're counting spaces over. And that's pretty much it. So the second one, we are going from this point over here on the left down to this point over here on the right, meaning what kind of slope do we have? Positive, negative, 0, or undefined? Negative. So whatever we get for our answer over here, it's going to be a negative number because it's going down as we look at it from left to right. So again, we need to go with the vertical change first. So from here, straight down, how far down do we have to go to get to the same horizontal distance from this point? How far down are we going? 3 spaces, good. So it's down 3 spaces, which means we're going to write a negative 3. So we have a rise of negative 3. And our run, we're going to go straight over now. Always look from left to right for the run, which means that the bottom number, the denominator, the value of the run, the change in x, whatever you want to call it, is going to be positive. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's plus 9 for the run. So minus 3 for the rise, plus 9 for the run. So we're going to say that m is equal to, we've got negative 3 over 9. And I want to go ahead and remind everybody real quick, the directions say to write your answer in simplest form, which means if you can reduce the fraction, and since I'm pointing this out, chances are you can reduce this fraction. Negative 3/9, what's that going to end up simplifying to equal? Negative 1, positive 3, negative 1/3. Good. So our slope ends up equaling negative 1/3. What that means, let me just show you real quick. That means that any point on this line, you can go down 1 and over 3 to get to the next point. I'll show you. So if we start here and we go down 1 and we go over 3, 1, 2, 3, look at that. There's a point right there on that line if we go down 1 and over 3. Same thing happens if we do it again. Down 1, 1, 2, over 3, right there. So simplify, there are points in between the two that we were given that work with this slope. A couple more on this first page. Let's have a look. Number 3, what type of a line is this? Yeah, it's a horizontal line, which means that the slope is 0. Yeah, so m equals 0. It's literally that easy when you have a horizontal line. That's all you have to do. M equals 0. Horizontal line, m equals 0. How about the next one? Take a look at your types of slope guide. Tell me what we got here. What's our slope? What kind of a slope is it? Or what kind of a line is it? Vertical line, undefined, yeah. So m equals, you can either write the entire word undefined. I usually just write UNDEF. I abbreviate it most of the time. Undefined slope when you have a vertical line. All right, we'll do the next 4 together as a class. And then I would like you after that to work on the final 8 that are on there. And then we'll wrap things up after that. And again, like I said, you're not getting an assignment today because it's a 2-day lesson. We're learning how to calculate slope from a graph today. Tomorrow, you're going to learn how to calculate slope given the slope formula. We'll see that tomorrow. So we're just going to keep working with our graphs for the day. So number 5. Is this a positive slope or a negative slope? Is the line going up from left to right or down from left to right? Up or down? Positive slope. All right. Let's see. I see a point here and I see a point up here. So we have to figure out how far straight up do we have to go first. So how far up are we going? Somebody count the spots and let me know. From this point to that point, how far straight up do you have to go? 5. Good. So 1, 2, 3, 4, 5. By the way, when you're actually calculating these, you don't have to draw the arrows. You don't have to write the +5. You don't have to write the word rise. I'm doing this as just an introduction until you get comfortable with this process. If you're comfortable with this process and just counting up and over and writing your fraction, I'm totally fine with that. But I just like to be really detailed when I first teach things. So how far over are we going? 3. And since run is always left to right, it's always going to be positive. So we've got a rise of 5 and a run of 3. So that means that your slope m equals 5 over 3. And since that doesn't reduce, that's your answer. Always reduce the fraction if you can. Something else I want to point out here that I didn't mention on the first one. What do you notice about the type of fraction that we have on problem number 1 and problem number 5? What types of fractions are those on for number 1 and number 5? They're both positive, I agree. There's another similarity in the type of fraction. Yeah, the numerator is larger than the denominator, meaning it's an improper fraction. And we kept it as an improper fraction. Do not change your improper fractions into mixed numbers when you're dealing with slope. 7/4 is the same thing as 1 3/4. 5/3 is the same thing as 1 2/3. But if you write them as mixed numbers, it'll be a lot harder to figure out the slope on the graph if it's a mixed number, because these numbers talk about how many spaces you have to count up and over. If it's a mixed number, it doesn't really give you that information. So leave the improper fractions as improper fractions. All right, number 6. Is this a positive or a negative slope? Negative slope. All right. So from this point to that point, vertically, how far down are we going? 3. Yeah, so that's a -3. How far over? 1. Okay. So down 3 over 1. So I'm going to write m equals -3 over 1. Now, you have an option here. You can leave this as -3 over 1, or you could just write -3. I would generally recommend, when you're writing the slope, generally I'm going to recommend using this first one, -3 over 1. Because if you have to graph something, the 1 on the denominator always reminds you that you have to go over. You always have to go over if it's a whole number. So, and I'll talk about that when we get to actually graphing these, but having a denominator of 1 with your slope is always, if it's a whole number, by the way, having a denominator of 1, keeping that 1 there, it's always going to be helpful in terms of the actual graphing process, which we will get to either later this week or next week. We'll see. All right, 2 more together, and then I'll give you the rest of the class to work on the rest of these on your own. So number 7, positive slope or negative slope? Positive, good. How far up do we have to go from this point to this point? 4, yep. So +4. And then what's our run? How far over? 2, yep. So +2. So up 4 and then over 2. So m, our slope, is going to be 4 over 2. Does that reduce? Yeah, what does it equal? If it was 2 over 4, yeah. But yeah, just 2. So we could say 2 over 1 or 2. So your slope is either 2 over 1 or 2. Again, I would recommend keeping the denominator of 1. You can write it as a whole number if you'd like to, but I always like to have a denominator with any slope that I'm writing. All right, number 8, positive or negative? Negative, all right. How far down do we have to go? Okay, so let's see, 1, 2, 3, yep, so -4. And then how far over? 4, okay. So +4, all right. So m equals -4 over 4. Does that reduce? Yeah, what does it equal? Yeah, it's So you can do -1 over 1 or just -1. All right. Let's see, we actually have quite a bit of time. I'm going to say, let's go until, let's see, 2, 4, so there's 8 left here. I'm going to say, let's go till 8 o'clock or 9 o'clock. Sorry. Let's go till 9 o'clock. And then at 9 o'clock, I am actually going to be calling on some random people to see what you get for your slopes on these. So that gives us about 18 minutes. Over the next 18 minutes, if you have questions, raise your hand. Let me know. I'm happy to help. I feel like that'll probably be enough time to finish these up. So, all right. So go ahead and wrap things up where you're at there. I am going to be calling on people. Just let me know what you got. And since we're learning this, if you don't have the right answer, that's okay. Just let me know what you've on your paper. If it's not exactly what it needs to be, that's fine. We'll work through it. That's what this is about right now, is learning. So let's go ahead and just jump right in. Let's see. First person I want to hear from is Caden. What do you have for number 9? Yeah. Was that -3/4? Yeah, nice. Good. The -3/4 for number 9. So to get from this first point up here down to this point down here, it's a negative slope because we're moving in a downward direction from left to right. Down 3 over 4, -3/4. Excellent. Thank you. Next is, let's see, Jimena. Do you have number 10? Not yet? Okay. Is it going to be, just show me with a point of a finger, positive or negative? Positive or negative? Negative. Good. And so on this one here, we're going down, straight down from this one to this one, vertically would be down 5. So -5, and then over 1. So down 5 over 1 is going to be a slope of -5 over 1, or just -5 if you want to write it as a whole number. However, again, I usually recommend keeping it as a fraction. Next, let's go to L. What do you have for number 11? Undefined. Good. Undefined for number 11 because it's a vertical line, and vertical lines are undefined. Let's see. 12. Emmanuel, do you have something for number 12? 2/3? Yeah, nice. From here to here, up 2 over 3, 2/3. Perfect. Positive slope. All right. We've got 4 more to go. Already went. Let's see. Creighton. For 13, yeah. 1/4. Nice. 1/4 for M on number 13. It's going up slightly. Up 1 over 4. Nice. Let's see. Already went. Caden, number 14. -1/2. Nice. So if you're working on this initially, you got -2 over 4 to start with, I'm guessing. If you have -2 over 4, that's not wrong. It just needs to go one more step to simplify it. Just make sure that you can bring that down to -1/2. And again, just as a reminder, when you can reduce something, that means that there are other points in between on this line. So if we go to this back to this original point, we can start here and go down 1 and over 2. And there's another point halfway in between the 2 that were there. So there's that point right there. We don't have to put this in on here, but that's what slope does for us. Is it actually shows us where those points are exactly on that line. All right, 2 more. Francisco, what do you have for number 15? 1/3? Nice. So we get 2/6 to begin with, and that reduces to 1/3. Excellent. So up 2 over 6 reduces down to up 1 over 3. So 1/3 for number 15. And then finally, number 16. Karen, what do you have for number 16? The last one there. 0. Nice. Horizontal line, left and right, is always a slope of 0. Well done. All right, so that's it for today's lesson.